The time is now. On everything. Took my heart away from money. I ain't interested in fame.
Hello, my name is Wesley. I'm here today to talk about final year projects with the University of Greenwich. Basically, I developed a smartphone solenoid switching and key replacement system, which is replacing car keys with a method of using a phone application to lock and unlock the car doors. Basically, because I finished that quicker, and my supervisor, Dr. Wilmelis, asked me if I was going to incorporate anything else within the project. So I opted to add buttons inside the vehicle that you can also lock and unlock despite having the mobile phone application, just make it easier for users who are already inside the vehicle. And I also incorporated starting the vehicle engine with a fingerprint. So before I get to the demonstration, I'd just like to show you this poster, which is a summary of the whole project, the reasons why, like the motivation, what motivated the use of the fingerprint scanner and the mobile phone itself, and well, introduction, design, implementation, testing and results. So before we get to the cool stuff, I'm just gonna be here and talk about all this boring stuff, so you get the basic idea of the whole project before I actually get to the cool stuff. So the vehicle keys have been in place since 1959, when the first electric starter was introduced. That's just a brief history. And James Script Booth in 1914 introduced the use of electric current to lock and unlock a vehicle. 1914. We're 2016 now, so that's why we're trying to move with times and incorporate all this with mobile phones. Motivation of a mobile phone. Well, a mobile phone today is one of those things that is being used for like internet banking, shopping, pretty much a lot of everyday use, that instead of going to the bank, you just flip out your mobile phone and do all those stuff like monitor your health and yeah. The fingerprint scanner, I chose that because security, there was a possible solution that I could have used GSM box. Basically, this solution was to start the car, or even lock and unlock the doors, or start the car itself using a GSM box. The GSM box, you use it to call. So basically, you have, let's say, a box that has a SIM card inside it. So you can install this box inside the car, then connect everything else to it. And then you have the mobile phone, you call a number, then that GSM box will send a signal for that car to do whatever you want it to do, whatever you've programmed it to do. But the problem with that is distance, because you're calling it or you're texting the car. So you text it, it unlocks, or you call it, the car starts. Basically, the bad thing about it, as I discussed with my supervisor, Dr. Wilmelis, was the range. You don't want someone having your phone and then calling while they're in China, the car is in England. The car will start as long as it gets the signal, a call from anywhere. So to minimize the distance itself, I opted to use Bluetooth with locking and unlocking with a range of like 20 meters away or something like that. So you're in range with the vehicle when you're unlocking it or locking it. So instead of a GSM box, I went for Bluetooth. And with the fingerprint scanner, I could have done the same thing with the mobile phone application to say the car should start with the press of a mobile phone. But yet again, you don't want someone stuck in the car while they're outside the vehicle itself. You want someone to get in the car and then start it. So a fingerprint scanner was the best solution to be able to achieve the starting and stopping of the vehicle while the user himself is already inside the vehicle, not outside the vehicle, just for safety precautions and all that. So GSM box was a possible solution, but I didn't choose that. I went ahead and used Bluetooth and a fingerprint scanner. So the objectives of the project was lock and unlock vehicle doors using a smartphone, communication to use short radio waves up to 100 meters, which is Bluetooth, use biometrics to switch engine on and off, which is a fingerprint. And the actual application itself, you might be wondering, well, someone can just have your phone and, well, they can have access to your car. No, that's why I included a secure application with a login with three security questions that only the user would know. So before you get to the actual application itself, before you open it, you have, as you can see here, three questions that you have to answer, and then, and then it will give you access to locking the car or unlocking the car. So you put your, this thing is messing up, but okay, we'll get there. Okay, yeah, there you go.
Just leave it.
Okay, yeah, so that's the application itself. When you first open the application, it says login now, and then you have registration, next MOT date, and the password. So someone might know your registration, they might know your MOT, they might really not know the MOT date and your password. So I could say that's really, secure for someone to, just get in there. So to kill time, I actually developed this save information on there that when you press that save information, you can save the registration and the next MOT date. Then you just have the user to put in the password if you wish to. So when you get back on the application, you still have those two fields saved. Then you just enter your password there. Then you open to the next page where you can unlock and unlock the vehicle. Yeah, so that's about the security of it. When wrong information is pressed, invalid. When wrong information is input, error, invalid info, please try again, that comes up. So back to where we were. Okay, on the design. The design itself, that's the block diagram of the system. I'm not going to bother to go into it. I'll just make sure I upload this so you can actually see how everything is as a block diagram, and that's the flow chart of the system itself. So start, internal button, external buttons that are outside, or smartphone application. So a user has, the option to go into the smartphone or the buttons, depending on where the actual user is. And I incorporated a safety button for the fingerprint scanner itself, because the way I viewed it is that you don't want someone just to get in the car, then they'll just put a fingerprint and start the vehicle. What if the car itself is in gear? So this will keep the actual driver in check. So this I developed a safety button, which, in other words, the safety button could be a clutch in the manual vehicle. So when the user steps on the clutch, it will give a signal for the user to now put the fingerprint on the scanner. The scanner recognizes the fingerprint, then the car starts, but without putting the foot on the clutch, which is putting the finger on the safety button. Without that, the engine itself won't start. So that was just a safety measure in case the vehicle is in gear. So yeah, that's the flow chart. Like I said, I don't want to go back too much into it, but you can actually view it later on. I'll make sure I put it on before I actually start the presentation itself. And basically that was the design part of it, and the implementation was done in two parts using smartphone application and push buttons. Like I said, that the push buttons were to lock and unlock while the user is inside the vehicle, because once you're already inside the vehicle, you don't need, or you don't want now to bring out the phone again and start, typing and all that, but you just have ease of access because you're already inside the vehicle. You just press a button, it will lock. You press another button, it will unlock. And then fingerprint was wired to switch an engine on and off. That's just, explaining that I used a fingerprint scanner. Basically, that was wired inside the microcontroller. I used the microcontroller to control all this stuff. And I had the pleasure as well to use a screen, as we can see on the results there, which will be shown in there. That will tell the user, basically tell the user of instructions to say, this is done, you may do that, or you may do this. Just instructing the user on what to do once they're inside the vehicle. Testing and results. The whole project was tested and everything worked as expected. I did black box testing and all that, white box testing and all that, and that's just a brief explanation of the results themselves. And conclusion is that everything worked perfectly. However, there might be further work which I didn't have enough time to do, which was to join the two codes together, which is locking and unlocking and starting the vehicle with the fingerprint. That means I developed two codes which both work, but I haven't put them together. So if I load a code for locking and unlocking, that works. If I put in the starting with a fingerprint sensor, that works as well. But I didn't have much time as I was racing against time to get the project done. So future work might be just to merge the codes together, which is pretty easy. Okay, so that's just a brief explanation of the whole system. Now we'll take a look at the cool stuff.
The time is now. On everything. Took my heart away from money. I ain't interested in fame.
We get to the fun part. Everyone knows my thing now, but it's cool. Okay. Applications. Key replacement. There we go. So the code is where's J. Done. The pattern save info was already there, so the info is already saved. Those two fields, like I explained before. So I press login. Comes on Bluetooth list and all that. So at the moment, as you can see on here, the Bluetooth light is blinking because the Bluetooth is not connected yet. So if you come over here, maybe, if I go on Bluetooth list, can you see everything? Okay, my Bluetooth is not on, that's why it's come up blank, so I'll put my Bluetooth on. Let's go back. Bluetooth list HC06, which is that Bluetooth module. Click it, the connection is established. As you've seen there, it's written connected, and on there the light is actually, steady, it's not blinking anymore. That means we're live. So ladies and gentlemen, if the actuators themselves, they're locked at the moment, when I press unlock, they will flip up. So let's try that. Okay, some connection somewhere is not right. Let's see where it's actually tripping. Okay, so they're unlocked. If I press lock, unlock, lock, 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 Unlock, lock. Okay, I'm just going to turn the lights off so you can see these the lights lighting up and going off. So at the moment it's on red because the actuators are locked. As you can see, those are 4-door actuators, so you know the 2 front ones and the 2 back ones, making 4. The red light is on because they're locked. If I press unlock, the green light comes on and the red light goes off, and the actuators, they're opened. Yeah, so lock and unlock, lock and unlock. Yeah, so I'll try to do it on a distance as well, so you see that, you know, it's Bluetooth, it's actually working, I'm not touching anything. There you go, you can hear a bit of noise. There we go. Okay, so that could be my vehicle over there. And inside the app itself, I made that message inside there that vehicle is locked, so the user will know that the vehicle is locked. And then when you press, okay, it's locked, but when you press unlock, it says unlocked as well. So there's the vehicle status on there. That's unlocked, and then it's locked. And then you can still hear the actuators going on and off. So yeah, locking the vehicle on and off works in a distance. Okay, so now I'm going to demonstrate starting the vehicle with a fingerprint sensor. Before I do that, I'm just going to demonstrate the buttons that, because this is when the user is outside the vehicle, but once the user is inside the vehicle already, they'll just press the buttons like, you know, locking and unlocking how you normally press the buttons. So it actually works the same way as the actual app itself. So that's locking and unlocking, and the lights behave the same way. Green light is unlocked, red light is locked, and the actuators go up and down as well, as you can see, as you can hear the noise themselves. So these are 12-volt actuators. They're actually universal car door actuators. Another thing I got lazy to do was to program the LCD to show lock and unlock. I didn't get to do that, but it's something that I can do in the future. Okay, so now I'm just going to load in the other code so I can demonstrate switching the vehicle engine on and off. This was simulated by this 12-volt light bulb. So when the vehicle, it's just like a vehicle engine. Since this light bulb is a 12-volt bulb, it's the same thing as starting the vehicle engine, which is a 12-volt. All you need is 2 wires to turn on and off. So if that turns it on and off, those wires can actually be used as a switch for the vehicle. So I'm just going to demonstrate that. Okay. I'm not going to take that as well. So this is scanner. So if I press that, it gives a signal to the scanner. I scan my finger. Image taken. And here says image taken. Engine starting. Then the light comes on. And then it says touch sensor to turn the engine off. So basically I'll need to hold that again to give, that's the safety button, which can be a clutch in the car. So with switching off, I can just put any finger on there which isn't registered, and then image taken again, not much found. Then, well, it's polite, it actually says thank you. It says to power engine, touch the sensor. So the engine is been switched off. As you can see, that light is off now. So I'll demonstrate that again. Press that, it gives a signal to the touch sensor. That's my registered finger. It takes the image, then it displays whatever, and then found match, light comes on. So it says again, touch sensor to turn engine off. So as I said before, that the light is actually emulating it's emulating the engine itself. So basically, for me to turn it off, I need to press that. This is my registered finger, and this is my registered finger. The other fingers, they're not registered, so I can use these two to turn the engine on, but I can use anyone's finger to turn the engine off. So basically, that's just a safety precaution, you know, when you're in a car, that anyone else can turn it off, but they can't turn it on. So here we go again. I'll try that little finger there, pinky finger, pinky. Not much found. Engine off, and then the light has gone off. Okay, so let's try that again. I'll try now my middle finger. Image taken. Found match. Engine starting. That's it. Light comes on. And after a few seconds, it comes on and display touch sensor to turn engine off. So we'll try to do that again. Turning it off. Just stand back a bit so you can capture everything now. So gives it a signal. So that's like maybe a clutch in the car. So the driver steps on the clutch. It gives a signal to the fingerprint sensor. Okay, we'll try that finger now to turn it off. Image taken, no match found, engine off. The engine turns off. Okay, now we'll try to turn it on at a distance. Middle finger again, which is registered. Found match, engine starting, comes on. So that's basically the demonstration of starting a vehicle with a fingerprint scanner. But first you have to have your fingers registered, so no one can just start your vehicle. Only you, the driver, can be able to do that. So basically the whole scenario, using the mobile phone and using the touch sensor, we're able to replace vehicle keys, which was the main scope of the project. So the project actually worked with the use of microcontroller, some buttons, fingerprint scanner, an LCD just to tell the user what's being done and what should be done next. So hopefully I'll push this project and actually install it in the vehicle, because all you need to do is install those actuators inside the vehicle, and the microcontroller itself is a 12 volt. As you can see, it's using an adapter, which is a 12 volt adapter. And that's the adapter for the actuators, because they need powering. So everything was used that was 12 volts. So basically, it just makes it easier to install it in the vehicle. So yeah, hopefully this is the future now. Get to drive a vehicle with locking and unlocking with a mobile phone, and starting the vehicle with a fingerprint. Cool. So yeah, that was the whole project. Thank you for watching.
The time is now. On everything. Took my heart away from money. I ain't interested in fame. And I pray that never change. Ambition is priceless.
No, it's
Something that's in your veins. And I
Only hope I had was selling. Was on my grind cause times was harder than the selling.
No, not you, but the people.
My mama taught me
that
never
will be
steal
watching.
and never telling folks. I grew up looking up the that was selling. Oh, I was raised by the stop sign. No religion, I was getting saved by the nine. By the minute, I was getting paid like a hotline. Serving rolling, fiends was calling. We was that kind, well connected, well respected and well protected. And get accepted, was rejected, now they regret it. And get my message, wasn't signal when I was texting. The I was calling was fraud and I learned my lesson. Now I move with aggression, use my mind as a weapon. Cause chances are never given, they took them like interceptions. So throw that pass, I'll be the cornerback. Me and Lauren, MMG gon' bring that Warner back.
My ambition. Easy to dream a dream, though it's harder to live it. They gon' love me for my ambition. Easy to dream a dream, though it's harder to live it. They gon' love me for my ambition. Easy to dream a dream, though it's harder to live it. Look, they gon'